Hi, my students in grade 6. This is a new mathematics lecture in semester 2. This is lecture 2. And in this lesson, as you can see, we have two titles. We will learn in this lesson two things. I put them or joined them in one lecture because each one of them is very simple to draw. It has a definition and a way of drawing. So here in this lecture, we're going to learn two important things in mathematics. Bisector of an angle, how or what is a bisector of an angle, and how we can draw a bisector of an angle. And the second title, the perpendicular bisector of a segment. How can we draw the perpendicular bisector of a segment? Objectives. Objective number 1, we will define a bisector of an angle. The definition is very important because it tells you how to do objective 2, which is draw a bisector of an angle. So I can draw a bisector from the definition. Objective number 3, we will define a perpendicular bisector of a segment. And objective number 4, we will learn how to draw the perpendicular bisector of a segment. Before I start with this lecture, in this lecture or in this lesson, we will be using these three rulers that you see in front of you. So before I start this lesson, these rulers should always be with you to start dealing with exercises related to this lesson. The first ruler, if you look here, we have seen this ruler before. This ruler is half a circle. We call it a semicircle. This ruler is called a protractor. You should all have a protractor with you in this lesson. The second ruler is the long ruler. Of course, all of you have used this ruler before. It is 0, 1, 2, 3, 4. It is enumerated in centimeter. The third ruler, we call it the set square. Let me talk a little bit about the set square. If you look at the set square, it has a right triangle shape. This is the right angle here. In this triangle, as you can see, we have three sides. This vertical side and a horizontal side and an oblique side. What we are going to use in this set square is the horizontal side and the vertical side and the small horizontal side. So please, these three rulers should be with you in order to do the exercises of this lesson. First, I will start with the bisector of an angle. So it's very important to know that we draw a bisector for an angle. So we should have an angle. We can draw its bisector. Let's define a bisector of an angle. Definition. This definition, you should memorize it, guys. Please memorize this definition written in bold. A bisector of an angle is a ray. So to draw a bisector, we will be drawing a ray that divides an angle into two equal angles. So after drawing a bisector of an angle, we will get two equal angles having the same measure. Again, this definition should be understood and memorized. I will read it again. A bisector of an angle is a ray that divides an angle into two equal angles. Given this angle here, we have angle MON. As you can see, angle MON has a measure of 60 degrees. So again, I am given an angle MON having a measure of 60 degrees. Of course, all of you should know how to draw an angle. We draw an angle using a protractor, the semicircle that I talked about a minute before. So first, we draw the angle MON equals 60 degrees, and I want all of you to practice drawing angles on draft. Now, to draw the bisector of an angle MON, we divide the measure of the angle by 2. Why? Because this is said in the definition. The bisector divides an angle into 2 angles. So because they are equal, we divide the given measure of the angle by 2. So I write 60 degrees divided by 2, it is equal to 30 degrees. Now, using the protractor, we assign the 30 degrees. What should we do? We put inside this angle the protractor, the zero, the half the semicircle on the vertex of the angle, and we assign or we mark on the measure 30. Here is the mark of the measure 30. After marking, this mark where I did it on the measure 30, I just join it with the vertex, so I get a ray. The ray is OT. So OT, which is a ray, as you can see here, is the bisector of angle MON. After drawing OT, the blue line, which is the bisector of angle MON, as you can see, we got 2 equal angles. Angle MOT is equal to 30 degrees, and angle TON is also equal to 30 degrees. Here, I want to tell you something very important. Let me repeat again, reading the angles. MOT, TON. As you can see, angle MOT and TON has the same vertex O, and they have a common side OT. So what can we say about the two angles MOT and TON? They are adjacent. So please keep in mind that after drawing the bisector of an angle, we get inside it 2 adjacent angles. Angle MOT measures 30 degrees, and angle TON also measures 30 degrees. Here in this slide, we will see together the steps, the exact steps of drawing a bisector. Suppose I gave you angle LMN. I don't know its measure. Simply, I bring the protractor, I put half the protractor on the vertex M, the zero line starting from the line of the angle, and I look. What's the measure of this angle? 0, 10, 20, 30, 40, 50, 60. So I write the measure of angle LMN is 60 degrees. Now, to draw the bisector, I again put the protractor inside angle LMN, and I mark or I assign on the 30 degrees. Now this mark, I bring the long ruler and I join it with the vertex M. I get This line, which is in orange, it is the bisector of angle LMN. So this angle here measures 30 degrees and this angle here measures 30 degrees. So after drawing the bisector of any angle, I get two adjacent and equal angles. Please practice this on a draft. Now, to draw the bisector of an angle, we use both rulers, the protractor and the long ruler. The protractor, we use it to measure the angle and to assign the half of the angle. The long ruler, we use it to join the marked number with the vertex. Here I have angle ABC. As we can see, since angle ABD here is equal to angle DBC, then not AD, then BD. Let me correct this, please. This is written by mistake. Then BD is the bisector of angle ABC. So BD will be the bisector of angle ABC. So angle ABD will be equal to DBC. And as I said, after drawing the bisector, we can notice that after drawing the bisector of an angle, we get two adjacent angles. The two angles ABD and DBC are adjacent since they have the same vertex B and they have a common side BD. Angles, as I said, yes, ABD and DBC are two adjacent angles. Now, there's a very important property of the bisector of an angle. Suppose I have angle BAC. I drew AD, the bisector of this angle. Then angle BAD will be equal to DAC. Now, if I asked you, let's take point D on the bisector. What can we say about D and the point M, which is on AC, and the point N, which is on AB? There's a very important property of the bisector of an angle, which says any point on the bisector of an angle is equidistant. What do we mean by the word equidistant? Equi means equal, distant means a distance. So equidistant means at an equal distance from the two lines of the angle. What does this mean? So DM will be equal to DN. Suppose here I have taken a point K, then KM will be equal to KN. Suppose here I have taken a point X, then XM will be equal to XN. So any point on the bisector of an angle is equidistant from the two sides of the angle or the two lines of the angle. Now, the second thing we are going to learn in this lesson is the perpendicular bisector of a segment. We have seen that we can draw a bisector of an angle, but the perpendicular bisector, we draw it for a segment. We all know what's a segment. A segment is a line having a known length. It has a beginning point and an ending point. This is the definition of the segment. Now let's define the perpendicular bisector of a segment. To draw the perpendicular bisector of a segment, it is a line, so we draw a line perpendicular to the segment at its midpoint. So here we should do two things in the perpendicular bisector of a segment. I will be having a segment. First, I should find the midpoint of the segment. Let me talk a little bit about the word midpoint. Midpoint means it is a point located at the middle of the segment. Anything at the middle, we divide it by 2. So to find the midpoint of a segment, we measure the segment and we divide the measure by 2. Let me give you an example. Suppose you have a segment which measures 4 centimeters. Where should we put the midpoint? I simply say 4 divided by 2 is 2. So I assign the midpoint on the 2 centimeter. Suppose I gave you a segment which is 10 centimeter in length. Where should be the midpoint? I say 10, the measure of the segment divided by 2 is 5 centimeter. So we should assign the midpoint of the segment on the 5 centimeter. Now, let me repeat the definition of the perpendicular bisector of a segment. The perpendicular bisector of a segment is a line perpendicular to the segment at its midpoint. I said, what do we mean at the midpoint? But what do we mean by perpendicular? Perpendicular means this line, after we draw it, it will make a 90 degrees angle with the segment given. To draw any perpendicular line, we should use the set square ruler that I showed you at the beginning of the lecture. Let me give you an example of how to draw the perpendicular bisector of a segment. Also, this definition should be memorized. Given a segment AB of length 6 centimeters, so I draw a segment AB, A at the beginning and B at the end, using the long ruler. It is 6 centimeters. Now, I want to draw the perpendicular bisector of segment AB. The first step is we should find the midpoint or the point at the middle of segment AB. I bring the long ruler, I put the 0 on A and the 6 centimeter will be on B. I say the midpoint is at the middle, so we should divide the measure of the segment by 2. So 6 divided by 2 is a 3 centimeter. So my midpoint should be on the 3 centimeter. On the 3 centimeter, I mark an X and I call it M. So M is the midpoint of AB. I want to ask you, what is the measure of AM? It is a 3 centimeter. What is the measure of MB? It is also 3 centimeter. So the segment AM is equal to the segment MB. That's why I use these marks on my drawing, a dash on AM and a dash on MB. This tells the one looking at your figure that AM is equal to MB. Now we bring the set square, we put it on the midpoint of the segment, and we draw a perpendicular at the midpoint. I call it line D. As you can see, line D, after drawn on AB, we make here the right angle since it is perpendicular to the line AB. Then the line D is perpendicular bisector of segment AB. Now, these are more examples. Line CD is the perpendicular, since we have a right angle here, bisector of AB. Since we have AD is equal to DB, then D will be the midpoint of segment AB. Also here we have another example. We have a segment AB. Q is the midpoint of segment AB. Since AQ is equal to QB, we have the same marks here. PQ, the blue line, is perpendicular bisector of segment AB. Now, also there is a property of the perpendicular bisector of a segment. Given a segment AB, I draw the segment AB. P is the midpoint of AB. I have put P, the midpoint of segment AB. Also, the mark AP is equal to PB. CP is the perpendicular bisector of segment AB. So I draw a perpendicular line at the midpoint using a set square. I got CP, the perpendicular bisector of segment AB. I want to ask you guys, where is C located here? C is on the perpendicular bisector. C is a point that belongs to the perpendicular bisector of segment AB. So point C belongs to the perpendicular bisector of segment AB. That's why we say C is equidistant from A and B. Do you still remember the word equidistant I talked about before? Again, equi means equal. Distant, it is a point at an equal distance from the 2 points A and B. What does this mean? CA is equal to CB. So any point on the perpendicular bisector will be equidistant from the two extremities E and B. Suppose again I have taken here down a point M on the perpendicular bisector. What can we say about M and the 2 points AB? Since M belongs to the perpendicular bisector, we say, then M is equidistant from A and B, which means MA will be equal to MB. So this is a very important sentence to always keep it in mind, never forget it. Any point belonging to the perpendicular bisector of a segment is equidistant from the two extremities. What do we mean by extremities? The beginning point and the ending point. So, my dear students, this was our lecture for this week. Please, I tried my best to make it very simple and very easy. Watch this video, understand it well, and everything, of course, will be fine with you. Thank you, my students. Until we meet, take care of yourselves. Bye-bye.